In this video, we'll talk about the divergence of a vector field. So the divergence of a vector field f with components f1, f2, f3 is the following function. We call it div f, and we compute it by doing the del operator dot f. That means we're doing partial derivative of the first component f1 with respect to x, plus the partial derivative of the second component f2 with respect to y, plus the partial derivative of the third component f3 with respect to z. Let's look at an example. So here we have the vector field f with components x, y, z, x squared plus z squared, and x e to the yz. And we're asked to find the divergence of f. So the divergence of f is the del operator dot f, which is the partial derivative of the first component of f with respect to x. So that's the partial derivative of x, y, z with respect to x, plus the partial derivative of the second component with respect to y. So that's the partial derivative of x squared plus z squared with respect to y, and then plus the partial derivative of the third component with respect to z. So that's the partial derivative of x e to the yz with respect to z. Calculating the partials, we have that the divergence of f is equal to y times z plus 0 plus x, y, e to the yz. And that's it. As you can see, this calculation is much easier than finding the curl of f. So what does the divergence of the vector field tell us? Again, we want to think about our three-dimensional space being filled with some fluid, and the vector field f represents the current inside that fluid. So at any point ABC, the divergence of f at ABC is a scalar that represents the net flow of fluid through a small box around the point ABC. Let's look at some more examples. So here we have the vector field x, y, 0. We have the following picture for this vector field. Now imagine that I have a point on this vector field, and I draw a small box around that point. Now notice that on the left edge and on the bottom edge, the arrows will point into the box. That means that fluid is flowing into the box on those two edges. On the top edge and the right edge of this box, arrows are going out of the box, which means that fluid is flowing out of the box. Now the divergence measures the net flow of fluid. Now for this vector field, the further I am away from the origin, the larger the magnitude of the vectors. So if I'm looking at the amount of fluid that enters the box and the amount that leaves the box, since the vectors leaving the box are larger than the vectors entering the box, I'm going to have a positive net flow of fluid going out of the box. So I should expect that my divergence is positive. So now let's actually calculate the divergence. The divergence of f is the del operator dot f, which means it's the partial derivative of x with respect to x, plus the partial derivative of y with respect to y, plus the partial derivative of 0 with respect to z. And this sum is 1 plus 1 plus 0, or 2. So again, whenever the divergence at a point is positive, we have more fluid exiting the box than entering, and we call that point a source. On the other hand, if the divergence at a point is negative, then more fluid enters the box than exits, and we call that point a sink. Let's look at one last example. So here we're looking at the vector field negative y, x, 0, and we're asked to find the divergence of this vector field. Again, let's start by looking at a picture. Now let's pick a point and put a box around it. Here you have fluid entering the box on the bottom edge and on the right edge, and you have fluid exiting the box on the left edge and on the top edge. So again, the divergence measures the net flow of fluid out of the box. However, in this example, it's not clear if more fluid enters the box or leaves the box. So let's just calculate the divergence. The divergence of f is the del operator dot f, which means I'm going to take the partial derivative of negative y with respect to x, plus the partial derivative of x with respect to y, plus the partial derivative of 0 with respect to z. Calculating the partial derivatives, I get 0 plus 0 plus 0, so the divergence of f is 0. This means that regardless of what point I pick, the net flow of fluid through a box around any point is going to be 0. This means that the amount of fluid entering the box is the same as the amount of fluid leaving the box. So in such cases, when the divergence of a vector field is 0, we say that that vector field is source-free or incompressible. So that's it for now. In our next videos, we'll talk about surface integrals and calculating the flux of a vector field over a surface.